So, in these examples, we're going to expand on our knowledge of factoring trinomials. Um, so, again, that first step is always to locate what your A, B, and C are. So, in this case, 4, -8, and 3. There's no greatest common factor that I can factor out. So, I go right into, okay, it has to add to -8 and multiply to 3. Well, that's not going to work. And also, we can't do the trick because A is not 1. So the first step that we do with this, okay, step 1, okay, is to do A times C. So we multiply. So A times C. So that's going to be 4 times 3, that's 12. All right. Now, step 2 for this is find the factors. Okay, so I'm going to take this 12 and I'm going to break it down. That's what it means by finding the factors. Finding what numbers multiply to get the result. So 1 and 12, 2 and 6, 3 and 4. Okay, now also I need to figure out for step 3 what adds to B. Well, B is -8 and C is 12. So that means these both need to be negative. And which two? Oh, the -2 and the -6. Those equal the -8. So now, step 4, replace into the original equation. So, what that means is now I have a 4-term quadratic. So, I have my 4x squared minus 2x minus 6x plus 3. Step 5, factor by grouping. This is why we covered factor by grouping in such detail in the last video. I group them in pairs. I look for the common terms. In this case, it's going to be 2x. So I'm left with a 2x here. And then when I keep the minus in there, remember to keep the additions or subtractions in there. And when I take out a whole term, 2 divided by 2 is 1. All right, the common term here. If I take out a 3, this first thing is going to be negative, and this is going to be positive. So I'm going to take out a -3 so that those signs flip and these two parentheses match. Now I have my first and my second binomial, and that is my factored form of that quadratic. So in this second equation, again, I'm going to repeat those same 5 steps. Okay, so the first thing I'm going to do is I'm going to locate A equals 6, B equals -11, C equals 3. So I have to do the long step in here because, again, A is not 1. So what I do, again, A times C. So that's 6 times 3, which is 18. Now I take this and I find the factors of this. So find the factor, step 2. So 1 and 18, 2 and 9, 3 and 6. And now I look for, okay, I kind of can play around with signs here, but if C is positive and B is negative, I know both of these are going to be negative. All right, which set of factors make negative 11? That's going to be this -2, -9. So now I'm going to replace the middle term, the B term, with these factors. So I'm left with 6x squared. And what a lot of students will ask me, does it matter which term goes first? And I'll tell you, no, it doesn't matter. So let's say you write it as 9x and then minus 2x and then plus 3. Well, that and 6x squared minus 2x minus 9x plus 3, they're going to get you the same answer. Okay, so what I do is, again, I factor by grouping. In this case, I can take out a 3x, so I'm left with 2x minus 3. In this case, there's no number that can go into that, so I always can take out a 1, but what you'll also notice is that I need this sign here to be a minus sign, so it matches up. So I'm going to actually take out a -1. So now, once I have my factor, oh, I got the 2x minus 3, I got the 3x minus 1. So, all right, so that becomes 3x minus 1, and now I got the 2x minus 3. Well, if I come over here with just rearranging those middle terms, now I'm just taking out a 2x in this case, but I get 3x minus 1. And I got a -9 and a positive 3. So I'm going to take out a -3 here, and I got 3x minus 1. Oh, look it. They come out to be the same thing. It's just a matter of which comes out to be inside the parentheses and which is the GCF for each problem. So it doesn't matter which way you organize it, as long as you know how to factor by grouping and to follow all of those steps. So in our next example, we're dealing with some pretty big numbers here. So what the first thing you have to do and think about in your head is, can I divide any of these numbers, or all of these numbers? Can I factor out a GCF? Can I divide them all by a number? That sort of thing. And if you notice, I can divide them all by 5. And then those numbers became a little bit more reasonable. So what I'm going to do is I'm going to factor out a 5. So that would leave me with 5x squared minus 13x minus 6. Now, what I can do is I can kind of forget about that 5 until like the end of the problem. So I notice A is 5, B -13, C -6. I know you're probably getting sick of me writing that out all the time, but it does help note that I can't do the quick method of factoring because A is not 1. So I have to do, and I always like to write this on the side, I have to do the A times the C. So I have to do that 5 times -6. So I got a -30. So now I am finding the factors of -30. So 1 and 30, 2, 15, 3 and 10, 5 and 6. And then once I get past that, I start repeating numbers, so I don't have to keep going on that. What you'll notice about this is a negative, and the B is a negative. And this is what really trips students up, is if the C is negative, you have to look at the sign of the B term. And if the sign of the B term is negative, the highest number in the factors is negative. If it's a positive b, then the highest numbers are positive. So you always go by what's the sign at b, and that gives the sign of the highest numbers. So in this case, a lot of students would automatically jump to 3 and 10 because they're like, oh, 3 plus 10, that's 13. I'll make them both negative. But two negatives multiplied together make a positive. We need a negative 30. So the trick with this is to pause for a moment and think. If C is negative and this is negative, then these need to be negative, which then means that the factors I need are not 3 and 10. I need 2 and negative 15. That is the key to this, is not to just always jump to the easiest addition ones, but to watch where your signs are. So now I'm going to replace, and now I'm also going to be strategic in where I place these things. So you'll notice that this is 5x squared. And I have 2 and I have 15. And if I am at all having trouble with my factoring out of anything, I want to put numbers in there that kind of go together. And you'll notice that the 5 and the 15 kind of go together. So I'm going to write it. And now I can factor by grouping. Well, I know I put those together because I could factor out a 5 and an x, so I'm left with this. And then if you notice here, they both divisible by 2, and I have x minus 3. Well, now I can combine that to x minus 3 and 5x plus 2, and that is my factored form of my, that is not the factored form of my original, because the first thing I did was I factored out that 5. So I have to go back and I have to replace that in the front. And now it's the factored form of my original equation. In our last example here, again, we're going to follow these same steps that we've always been following. So first off, you should notice that all of these are divisible by 2. So I'm going to make a nice, easier problem. All right, so now I've divided all of them by 2, factored out that 2. So now my A is 3, B is 1, C is negative 10. All right, so now what I'm going to do is I have to do my A times my C, which is going to be 3 times negative 10, which I get another negative 30. So now that negative 30, I break down into all my factors, and I look, oh, again, this is negative, okay, but B in this case is positive. So that means that these are going to be, my bigger numbers are going to be my positive numbers, and these are going to be my negative numbers. So I can immediately realize that to get 1, I need a negative 6, or a negative 5 and a 6. So I'm going to replace that middle term, and I'm going to be strategic with it, because 3 and 6 kind of go together, 5 and 10 kind of go together. Again, does it matter? No, you'll get the same answer either way, but sometimes it helps students think, oh, 3 and 6, oh, and that's obviously a 3x. And 5 and 10, and both negative, oh, that's going to be a negative 5. So now I'm left with the 3x minus 5, the x plus 2, and I did factor out that 2 in the beginning, so I'm going to put that at the end, and that is the factored form with these quadratic trinomials when a is not 1. All right, so why don't you guys go into the night and save your day.